Good day. My name is Dr. Anumendem Dixon Kafu, and welcome to the Math Salon. The Math Salon is intended to help students preparing for their GCE examinations, ordinary and advanced levels. The Math Salon intends to make mathematics much more attractive and beautiful to students following this course at the ordinary and advanced levels. What the Math Salon does is that each time we get a question that is modeled for the GCE, advanced or ordinary level, and we try to solve them step by step, trying to give as much information to the student as would be required to solve this particular problem and others very close to it. You can provide us as well with some past questions. If you have soft copies or scanned copies, that will be preferable. I hope you get to like it. Thank you. Today, we will be looking at differentiation from first principle. And the question that we'll be looking at today says, given that y is equal to sine x, find dy dx from first principle, where x is in radians. So I think it's important to remind ourselves of what does first principle mean in terms of differentiation. So the first principle indicates that if I want to differentiate a function in x that I can call y with respect to x, of course, because it's in a function of x, then that will simply be looking for the limit as delta x, small, very small change in x, or the change goes very, very small to 0 for the function f of x at x plus delta x minus the function at x divided by delta x. So we will just proceed. So in order to be able to use this formula here, what we need to do is get this function, and then we stick them into that and look for the limit, and we are done. It's so simple. So first, my function f of x, according to the equation, is given as sine x. So it's simple, I already have this one. Next, I need to look for f of x plus delta x. So f of x plus delta x, what does it mean? It's a function. It says, if you have something, I put it into it. This function is a sine function. So if you give me x, I will get the sine of x. If you give me x plus delta x, I will get the sine of x plus delta x. So you see, I would fit that exactly inside that. So I already have these two functions that are required to put into my formula. So that means my dy dx, where y is sine x, is equal to the limit as delta x tends to 0. I've just copied this part. Now here I would substitute, I will replace the information I have. The first one is f of x plus delta x. It is sine x plus delta x. So I put the sine x plus delta x there. And the second one is f of x, is just what was given to me. I have sine x, of course, divided by delta x as given there. If that is true, then it means I am now left to just look for the limit of this function. In order to be able to get the limit of this function, I have to make sure that, I'm able to use some of the properties of limit that you would have learned, or at least we would see at another time when we come to a question concerning limits. In this case, I would like to simplify this top. But to do that, we have to look back into our factor formulae from trigonometry. In the factor formulae, we learned that if I have sine A minus sine B, then this will be equal to 2 times the cos of the sum of the angle divided by 2 sine the difference of this angle divided by 2. This formula you must have proven during your trigonometry topic, or at least I just reminded you here about it. This is what we are going to apply at this point. So I have sine here minus sine here. So this is my A and this is my B. I will apply that there. So this is my A and this is my B. So it is 2 cosine, there's a 2, the cosine of the sum of those two angles, that means x plus delta x plus x plus delta x divided by 2. And the sine of x plus delta x minus x divided by 2. I can simplify this here. X plus x is 2x. 2x divided by 2 is just x. And I have delta x divided by 2, so I get this expression here. Here, x minus x falls off. I'm left only with delta x divided by 2. And I get that there. So this is my simplified version of this, and I can stick them back into the formula for the limit. So the limit of delta x tends to 0 of 2 sine x plus delta x on 2, sine x plus delta x on 2 divided by over this delta x is from the formula. The delta x is coming from here. I have a 2 here. In order to play around, in order to get a limit, I recognize that I have some limits that I already know from before. It's like in a salon. If people come and they show you the picture of a hair that they would like to get, you can check back to the hair of some other person that you did. If it's exactly the same thing, and use that information, then the work becomes easier. We do the same here. So multiplying by 2 is the same like dividing by half. Of course, if you're dividing by half, you have to invert, right? So it's multiplied 2. So it's the same thing. So here, 2 here, I can put the 2 below. I can always turn it back to get the 2 up, and the delta remains under. But by so doing, I split my limit into 2 parts, whereby limit properties, the limit of this product can be the limit of this first part multiplied by the limit of the second part. From the first part here, I can already get the limit. The limit is just taken, if delta x tends to 0, then this part tends to x. Yeah, because then this is just 0 divided by 2, and that's 0. Or something very, very small divided by 2 is just about 0. So this can reduce to the limit 2 cos x. At this other side, it's a bit more complex there. The reason for which I had to play with the 2 to come here, because I recognize that we can prove very well, of course, I'm not going to do at this particular point in time, but you can check back into your books to see that the limit of the sine of delta x on 2 divided by the delta x on 2 as delta x goes to 0 is 1. And therefore, my differentiation for the sine x is simply cos x multiplied by 1. But this is only possible if x is measured in radians, not in degrees. So if your x is measured in degrees, then the formula doesn't work. That is why it was given in the equation that x should be in radians. If that is true, then it means the differentiation of the function y equal to sine x by first principle ends up being this. So the derivative then of sine x is simply cos x. Thank you.